Page 27. Yeah. Thermal physics, classified paper 4, thermal physics, page 27. If you don't have the paper, you can use the screen. Water has a specific heat capacity of 4,200 joules per kilogram degree centigrade. Means to increase the temperature of 1 kilogram water, we need 4,000. If to increase the temperature of 1 kilogram water by 1 degree, we need 4,200 joules. Because specific heat means how much energy is needed to increase the temperature of 1 kilogram substance by 1 degree centigrade. And the boiling point is 100, means the temperature at which the water will turn into a liquid, will turn into a gas. What is meant by a boiling point? What is meant by a boiling point?
Boiling point?
Yeah.
The maximum heat capacity of
The point at which the liquid turns into vapor.
So temperature at which the liquid turn into a gas, we call that. No, evaporation is different. Evaporation can happen at a range of temperature. Like it's not like boiling of a water, a pure water is 100, but evaporation of a water can take place at even 25, 30, 40, any temperature. So what is meant by the boiling point? The definition of a boiling point? So it is a temperature at which liquid turn to gas. That's it. If you write temperature at which the atmospheric pressure equals to vapor pressure, that is also correct, but not related to the explanation here. Here you just need to mention a temperature at which a liquid turn to gas. And when a liquid turn into a gas, at that point, atmospheric pressure is equals to vapor pressure. That is the explanation of a boiling point, but not the definition. Definition is temperature at which a liquid turn into a gas. Next is a mass of a 0.3 kilogram water. So we have, because it is related to the previous part, a mass of a 0.3 kilogram of a water. So we have the mass of a water which is 0.3 kg is poured into a copper container, initially 11. So the starting temperature is 11. After a few seconds, the temperature of a container and the water are both 95. So final temperature is 95. The specific heat capacity is already given to us. That is 4,200. Energy transfer. How to get the energy transfer if we have the specific heat capacity? So we use the formula energy transfer or energy absorbed or energy given out or energy taken in is equals to specific. It's the same formula. So energy absorbed, energy release, energy given out, taken in when there's a change in temperature. So energy Cm delta T. What is delta T? Delta T is the change in temperature. So whenever you solve a question in physics, always write a formula. 1 mark is for writing a formula. And I have already shared the formula sheet. Try to memorize these formulas.
So what does C stand for?
C stands for specific heat capacity. So what is the specific heat capacity of a water here? (4,200) multiplied by mass. What is the mass? 0.3. Remember one thing, if the unit of the specific heat is joule per kilogram, then the mass should be in kilogram. If the unit is joule per gram, then the mass should be in gram. Multiplied by temperature change. Multiplied by temperature change. So what is the temperature change? It is 95 minus 11. What's the answer? 4,200 times 0.3 times 95 minus 11, which is 84. So whenever in a question you see a change in temperature, Whenever in a question you see a change in temperature, so what formula you will use for energy? Just remember this formula that energy is equals to specific heat into mass into temperature change. Whenever there is a change in temperature. What's the answer?
105,800.
Press ENG on your calculator.
105.84 multiplied by 10 power 3.
185?
105.
105.
105.84
105.84
Okay.
multiplied by 10 power.
multiplied by 10 to the power of 3.
So 10 to the power 3 joules. So I can say 106 exponent 3 joules.
Yes. Is it necessary to
So remember this formula whenever you see a question related to temperature change. So energy is equals to Cm delta T. E equals Cm delta T. So if in the question specific heat is given to us, mass is given, and the temperature change we calculated. Where C is a specific heat capacity. Yeah. The next is calculate the thermal capacity. That part is removed from the syllabus. Now you don't have to learn the thermal capacity. If you need a formula, look, it's the same formula. Look, if you have energy is equals to Cm delta T. So if you need a specific heat, you just divide mass and temperature change. So energy divided by mass into temperature change, that will be specific heat. You just change the subject according to the requirement. Next. Water from the container evaporates and and the temperature of remaining water decrease slowly. So we have a container. We have a container and the water is evaporating. So explain in terms of molecule why why evaporation cause the temperature of a remaining liquid or a water to decrease. So what will happen? 3 parts. So when the evaporation happen, yes.
The molecules with the greater kinetic energy increase, escape the liquid, and the lower kinetic energy molecules with the lower temperature are in the water. That's why it is. And also evaporation is an endothermic process, so that it
You can see from there. Yes, now. Yes, Arham.
So I
Yeah.
think that the molecules will take energy from
The most you one mark most energetic molecule gain energy,
gain
escape,
energy to escape
right?
escape the water.
But that is 1 mark. Like 1 mark is for mentioning most energetic molecule
No
escape.
bubbles.
No, you don't write. You don't have to write difference.
and the lower
Yes.
the molecule with the lower kinetic energy stay in the liquid, and they have the lower temperature because
From the top of the
kinetic
water.
energy and temperature
That's the second
type of directly proportional.
The second mark for this.
From the top of the water.
Look, first is most energetic escape. Most energetic molecules gain energy from the surrounding.
One mark.
And escape. That is one thing. The molecules which are left behind have low energy So as a result, the temperature, the kinetic energy will decrease, like the particles will have low kinetic energy, so the temperature will also decrease. See the distribution of the marks, for every structure question, there are answers. So 1 mark for mentioning what? Molecules overcome the attractive force and evaporate. Like they break the force of attraction. The most energetic molecules escape, likely to escape, and the molecules which are left behind will have a low energy. Clear?
The particles will be increased, right?
No, remaining energy of the particle will decrease.
So it can be like plus 4 in that here. So
The most energetic molecules gain energy from the surrounding, overcome the attractive force, and escape. That is the same thing. If you mention most energetic molecule, gain energy from surrounding, escape. That is actually giving an idea that it overcome the attraction or did the work done against the other attractive force. So if you say most energetic molecule gain energy from surrounding, that is the same point. Next, an aluminium saucepan with a plastic handle contain a cold water. The figure 4.1 shows a saucepan on a hot plate, aluminium saucepan with the water and a hot plate at the bottom and the plastic handle.
Sir,
Yes,
is a hot plate.
to heat a substance, like example, to provide heat energy to a substance, we can use these hot plates. Electric, like it convert electrical energy to heat energy. So instead of having the stove, you can use these hot plates. Electric stove, yes. That's electric stove also. It's containing the top is a metal, which is a hot plate. State why the pan is made up of aluminium, but the handle is made up of plastic. Yes.
Because aluminium is a good conductor and plastic is a bad conductor. We don't need the plastic to get hot, we need the aluminum to get hot. So that's
So you don't burn your hand, but the
Plastic is good insulator.
is made of aluminium, so the water
Plastic.
can get heat.
Yes.
So plastic handles do not conduct.
So plastic is insulator, does not conduct. That's one point. And aluminium is a conductor. So it provide the heat energy or conduct the heat energy to water or transfer heat energy to water. Like when the hot plate, how the energy transfer between the hot plate and aluminium saucepan? Which method?
by
with
conduction.
conduction.
By conduction. Whenever two different surfaces are in contact, it's always by conduction. Same thing how convection is a transfer of heat energy by the actual movement of molecules. Conduction is a transfer of heat energy by vibration of the molecules. So here what will happen? This is a hot plate. So a hot plate, molecules in the hot plate will vibrate, collide with the molecules of the aluminium. That is conduction. And aluminium also transfer energy by conduction. But how energy transfer within the water is by convection. Because the most energetic molecule, like the molecules which are having a greater energy, they rise, and the less energetic molecules will move down. So the points you will mention, aluminium is a good conductor, allow heat energy to pass or transfer, and plastic is insulator, does not allow heat energy to transfer. So that's why it is used in the handle, as the handle. The hot plate is switched on, and as the temperature of a water increase, the internal energy of a water also increase. State in terms of molecule, what is meant by internal energy? What is the meaning of internal energy?
The
No,
total kinetic energy and potential energy of molecules. Sum of kinetic energy and potential energy of the molecule.
So yeah, what is internal energy? That's right.
Chemical.
No, chemical energy is not internal. Chemical energy is a stored energy, but it's not internal energy. So no, what is meant by an increase in internal energy? What is internal energy? Internal energy is a sum of kinetic and potential. So what is meant by increase in internal energy? So we'll say the sum of kinetic and potential energy will.
That potential minus.
Clear definition, sir.
Yeah.
Clear definition for it, right?
Yeah.
To give that number.
So internal energy is a sum of kinetic and potential energy. And the question is what is meant by increase in internal energy? So we'll say the sum of kinetic and the potential energy will increase. Because question is not define internal energy. Question is what is meant by increase in internal energy? What is the meaning of the term increase in internal energy? So the term increase in internal energy means that the sum of kinetic and the potential energy will increase.
Right.
So chemical energy, strained energy, nuclear energy, these are not internal. Internal energy is the energy of the particles, which is the sum of kinetic and potential of the particles. State in terms of molecule, what is meant by increase?
This is the same one.
Explain in terms of molecule, explain in terms of atomic lattice and electrons, how energy is transferred through aluminium. You have to explain conduction. So how we explain conduction? Anyone want to answer? Conduction, explain it.
Yes.
Uh,
Sir, when one atom gets heat, it transfers heat to other atoms, and when the electrons also they move around the atom, move around the aluminium, and transfer the heat throughout the aluminium.
Two marks. Sir, how much is
The total 3 marks are there. One is explain in terms of atomic lattice and electron. So atomic lattice is its transfer of energy by the vibration of the lattice, vibration of the particles in the lattice, and by the movement of electron from a hot region to a cold region. And the distribution you see hot to cold. So atoms touching the hot plate, lattice vibration is there. Then the vibration to the neighbor atoms or to other atoms. And then the atom passes energy to electron and electron hit the distance or movement of electron. Like they mention any three you can write from here. So the structure of this answer, what we'll say? We'll say explain in terms of atomic lattice and how thermal energy transferred through the aluminium. So the collision between the particles of hot plate and aluminium so when the particles of a hot plate and aluminium will collide, it will cause lattice vibration. Yeah. No, a hot plate, first we have a hot plate and aluminum pan is placed. So when the particles of a hot plate collide with the particles of aluminium, they transfer energy. Then this collision causes a lattice vibration. It causes a vibration of the lattice in the aluminium. The particles are vibrating. So it causes a lattice vibration which transfer to the neighbors. So which transfer to the surrounding molecules, okay? And then what will happen? The movement of electrons from the hot region to the cold region transfer the energy as well. So first the collision between the particles of the hot plate and the aluminium collide. Then the collision of this causes a lattice vibration in aluminium. And in a lattice vibration of aluminium, the neighbor of aluminium transfer energy until it is transferred to the other end. And same thing, electrons also move from one place to another. Clear about this? Wait.
had to remove it.
Lattice means a regular arrangement of the ions. When ions are arranged in a regular manner, we call lattice. So in the metal, the structure of a metal, it consists of a lattice of positive ions and the delocalized electrons. So there's a positive ion. So lattice vibration means that these positive ions start to move. This is lattice vibration. When this is vibrating, this transfer energy to the neighbor, this transfer energy to the neighbor. That's how the energy. And another thing what happened is a movement of electron. Electrons also move from one place to another. Both are causing the transfer of energy. Eventually, the water reaches a boiling point. The thermal energy from a hot plate is still being transferred to the water. Explain in terms of molecule the effect of thermal energy on water. Like now, water is boiling. Water is converting into from liquid to gaseous state. So what happened to energy which we are supplying? What happened to this energy? No, we are supplying the energy constantly. What is happening to the energy supply? Where it is used? Water is boiling.
To overcome the forces of attraction and the vapors, the molecules will escape as vapors.
Yeah, good. The molecules have bonds between them. Okay, the water molecule attraction. So the energy which we are supplying is used to break the bonds between the atoms or a molecule. And when these bonds break, the molecule will escape. That is what is happening here. So what are the points we'll include? We'll mention the energy supplied is used to break the force of attraction or the bonds between the molecules. And it's of 3 marks. So how you explain? 1 mark, you can see bonds broken, attractive forces, it overcome. 1 mark, the molecule escape from the liquid. And 1 mark, molecule gain potential energy. Why we say potential energy? Because the molecules are rising. So when the molecules are rising, what they gain? Potential. So answer is very simple and it's of 3 marks, which means a high weightage. Because in IGCSE, usually like you have 4 mark question. You don't get 6 mark or 8 mark question. On average, it's 2 to 3.
Average is 2, right?
So during a picnic on a warm, dry day, a metal can of a lemonade is wrapped in a damp cloth. What? Evaporation cool the water in the cloth. Explain in terms of molecule how evaporation cool the water in the cloth. So
It takes 5
look, during a picnic on a warm, dry day, a metal can is there. So metal can of a lemonade is wrapped with by a damp cloth. So the damp cloth is there on the metal can. So what will happen? The most energetic molecules on the from the damp cloth will take energy from surrounding. But what is the surrounding? The surrounding is a metal. So most energetic molecules in the damp cloth will take energy from the can. When they take energy from the can, the molecule will escape. That is why, like example, in case of a person is having a high fever, a very high fever, so what they do? They damp the cloth and place it on the forehead. So the no, that's home treatment. Home treatment is what is the reason for this home treatment? So because evaporation is a cooling process. Because when your body temperature rises too high, then the enzymes in our body, the biological catalysts, they start to deform.
Yes.
So the function, some organ failure also it can result because of a very high fever. So as a result, it may lead to death. So what you have to do in case of a high fever, a damp cloth and place it on the forehead of a person or a patient so that it will cause a cooling effect to the body. So same thing, if you have a metal can and you don't have a refrigerator, so you can do just take a cloth, just wet, like make it wet, and then wrap around that metal can and leave it for some time. You'll find the metal can will cool down. It's not like it will be refrigerated, but it will cool down below the room temperature. Like if a room temperature, let's say 30, but the metal can temperature might be 24 or 25. So it will cool down. Like a sensation will be there that it is cold. It's not like refrigerated. I'm not saying it will be refrigerated.
If we take tea and put a water cloth
Yeah.
on it, it will cool down.
Yes.
The tea will cool down.
Yes, definitely.
Okay, so.
So what will happen? The molecule, the most energetic molecules gain from the cloth, gain energy from the metal can and escape. The molecules which are left behind have low energy, which cool down the can. So this technique can be used in a place where you don't, like even in case of a heat wave. In case of a heat wave, what we can do,
Put it down.
because
So,
yeah, use a damp cloth and place it around your forehead or a head or your neck. Place it around this part so that it will cool down your body. Because in case of a heat stroke, the surrounding temperature is so high, then your body temperature start to increase as well. Because when there's a greater difference between a temperature of surrounding and the object, the greater rate of heat energy transfer. The most energetic molecule from a cloth gain energy from the metal can and escape. The molecules which are left behind have low energy because the most energetic molecules escape. So the molecules which are left behind, their energy will be low. That's why it will produce a cooling sensation. Is it clear, this question? Any doubt?
Yes, sir.